So yesterday we discussed the distributive property and how we could use it to not only distribute terms to things that are inside of the parentheses, but also how we could use it to multiply a double digit number. If you recall from yesterday, we had that cool little thing where if, let's say, somebody asked me to multiply 8 times 46, I could look at it as 8 times 40 plus 6. And that would make it a little easier to multiply because 8 times 40 is just 320. 8 times 6 is 48. And 320 plus 48 is 368. To the point where we can almost do that in our head. So that was one way that we used the distributive property yesterday for something realistic, some application of it. I want you to consider as we start today, because a couple people asked, what would happen if they were both double-digit numbers? So what if somebody said, multiply 12 times 14, but use the distributive property to do it? You can't, okay? What we're going to do is we're going to take the idea that we did yesterday where we split them up. We're going to split up both of these numbers, and then we're going to distribute. Thing is, how do we distribute something like that? Because let's say we make 12, 10 plus 2. We make 14, 10 plus 4. Well, how do you distribute this to this? That's what we're going to look at today. And that's going to be the process of double distribution. And that's what you saw as today's sort of leading question. How do we use double distribution to multiply some things? So let's start with this problem, 12 times 14. Let's split it into 10 plus 2 and 10 plus 4 because multiplying by 10 is relatively easy. And let's explore how we would multiply this thing. Okay, this process is going to be called double distribution. You'll hear some teachers maybe at some point call this what we're about to do foiling, because the F stands for something, the O stands for something, the I stands for something, so does the L. But I'm going to you're going to hear me call it double distribution. Okay, we're going to distribute twice. So first we'll distribute the 10 from here to both the 10 here and the 4. So 10 times 10 is 100. I can do that in my head. 10 times 4 is 40. I can do that in my head. Now, here's where the double distribution gets its name. We are now going to take the 2 and distribute it to the 10 and the 4 as well. 2 times 10 is 20. 2 times 4 is 8. And then I just add those up. 100 plus 40 plus is 140, plus 20 is 160, plus 8 is 168. So 12 times 14 is 168. And I call that double distribution, distributing twice. Now, why do some teachers call it FOIL? Well, because the F stands for first. You're taking the first term here and multiplying it by the first term over here. Then you're taking the O, that's the outside term, to this outside term. Inside terms, that's the I. And then the L stands for the last terms. I don't get into that because people then think they have to memorize it. Just double distribute. Distribute the 10, then distribute the 2. Add your pieces up, and you got it. Okay, now let's try one all on your own. Take a look at these. 18 times 26. I have no idea what 18 times 26 is off the top of my head. But if I think about it enough, I would know how to split up 18. 10 plus 8. That probably would be the easiest way to do it. Always working in tens is because multiplying by 10 is easy. Then 26. So 20 plus 6. Then I just simply double distribute. 10 times 20, 200. 10 times 6, 60. 8 times 20, 160. 8 times 6, 48. Now, there's a few more things I have to add together here. 200 plus 60 is 260. plus another 160 is 320, plus 48, 368. 18 times 26 is 368. Now, I get it. You're probably thinking to yourself, well, I could just take a calculator out and multiply 18 times 26. Sure, you could. But the purpose of what we're doing here is to try to show you this process called double distribution so that when you get a problem that's not just numbers, you can still multiply. What do you mean? I mean, take a look at this thing. Not this. That was yesterday. This thing. How do you multiply x plus 2 times x plus 3? Do I distribute the x? Do I distribute just the 2? How do you multiply this? Well, if we take what we just did with numbers and apply it here, it really shouldn't be that big of a deal. Let's distribute one piece at a time. So let's start with our x. X times x. Well, for those that don't remember, x times x would give me x squared. X times 3, 3x. Then I'm going to take my positive 2, 2 times x, 2x, 2 times 3, 6. Look to see if there are any terms that are alike. There are. These ones are. Add them up. 3x and 2x gives me 5x. X squared plus 5x plus 6. Now let's just make a note that I can't combine anything else because there aren't any more like terms. So that's my final answer. X squared plus 5x plus 6. But that's multiplying two algebraic expressions by using double distribution. Okay, let's try one more. I'll add a little bit of a challenge to it in that if you notice, what I've done is, let me see if I can take that off. Yeah. I've added that it's not just an x, it's a 3x. There's a negative in there. So I've tried to add a couple of little challenges for you. But the idea still remains the same. At this point, we can double distribute. 3x times 2x. Now, if this is still something you're struggling with, like you don't know what 3x times 2x is, we'll do a whole unit on multiplying things that have variables in them. But 3x times 2x is 6x squared. Anytime you multiply x times x, you end up with x squared. 3 times 2 is 6. 3x times 4 is 12x. Then negative 2 times 2x is negative 4x. And negative 2 times 4 is negative 8. Again, that process of double distributing everything. I just got to remember that in this case, and let me highlight it, I looked at this as a negative 2 that I was distributing. So you got to kind of keep that in mind. Now I noticed that these are like terms, so they can be combined. And in the end, we're going to end up with a final answer of 6x squared plus 8x, negative 12x minus 4x, or positive 12x plus negative 4x is positive 8x minus 8. Done. And I leave my answer just like that. There's no other like terms there that can be combined. And now I've just double distributed to multiply two algebraic expressions. Okay? We call that multiplying binomials. Again, that'll come up at another time. But for right now, just know that you just multiplied two algebraic expressions by using double distribution. Okay, that'll be it